So one of my students, whose name is MD, wanted to get some help about some problems with the ACT question. Excuse me, I'm going to skip number 9. We'll maybe go over that a little bit later on, but I am going to do this problem for you. 2x minus 3, let's use pink for now. 2x minus 3 times 3x squared minus 2x plus 5, 4. The first thing we're going to need to do is, this is not the exact problem that my student has, so we are going to modify it a little bit, okay? And then you can do your problem just by matching it up. You have 2x right over here, and then minus 3, which is the first factor. Then you have 3x squared minus 2x, and then plus 4. That's your top. So make sure you separate them out, and that's why the box is so important. So the first left top box, 2x times 3x squared, 2 times 3 is 6, x times x squared is x cubed. Now 2x times negative 2x is minus 2 times 2 is 4, and then you have x times x is x squared. Then you did the right, you go just in order. This way, and then this way, right? Let's erase that. Okay, the last thing you do is 2x times 4. 2 times 4 is 8, and you have an x. You only have one x so far, okay? Because there it is right there. Let's do the second row. Negative 3 times 3x squared is negative 3 times 3 is negative 9x squared. Let's try that again. 3x squared times negative 3, right? So this means 3 times x squared. So 3 times negative 3 right there is going to be negative 9x, and then you have 2 of those x squared. Negative 3 times negative 2 is positive 6x. Negative 3 times positive 4 is negative 12. And what you will notice is that, let's use purple. The diagonals here will always add up. The diagonals here will always add up. Okay? So you end up with finally 6x cubed minus 9x squared minus 4x squared is minus 13x squared. And then 6x plus 8x is 14x. And then minus 12. That's how you distribute that out. You can go slower if you want, just by pressing the pause button if you want. Let's do the next problem. You have 8 times quantity x plus 2 times x minus 2. There it is right there. And then you have 4x squared minus 16 in the denominator. We are going to have to factor this to see if there's any like factors that we can cancel the numerator and the denominator. So between this right here, you always have to factor it out. So I'm going to write down 16 as 4 times 4. Here I'm going to write down as 4 times 1. The common factor, as you can see with the pink, is 4 and this 4 right here. So you factor out the 4, and let's see, let's use purple. What's left is going to be x squared, and then minus, you factor out that 4, you have 4 right here. If you're not sure, just distribute that out. You should end up with what you had earlier. Okay, so I'm going to cancel that for now. Now, here, this is going to be a difference of squares, right? The difference of squares says it's going to be x. Let's rewrite x squared minus 4. Same thing as something squared minus something squared, right? What goes inside here? It's going to be x squared minus 2 squared. That turns out to be 4. So the factors are going to be in the form x plus 2 and x minus 2. You notice that these are called conjugates, right? We learned about conjugates earlier. So you end up with this as the denominator. You end up with this as the numerator. Now, what you can notice is that 8 is something as, I'm going to use turquoise. 8 is something as 4 times 2. That's fair, right? And so what happens now? This 4 and this 4 cancels. Don't forget, this 4 and this 4 cancels. X plus 2, x plus 2 cancel. One numerator, one denominator. X minus 2, x minus 2 cancel. You end up with only this is what's left. X 2 over 1, which is taking as 2. Okay, last question. Now, if a lot of students of mine have a hard problem reading this inequality, I like to read it this way. A right there is between 0 and 1. Again, this number A right here is between 0 and 1. Now, I want to put a value for A. I don't care what value you're going to put in, but just unless it's between 0 and 1. Most of my students say A would be, think about it, what's a good number to use between 0 and 1? 1/2, right? So the function would look something like this. F of x would equal 1/2 to the x power. Now, as x increases, what happens to my output? Let's say x was 1. What's 1/2 to the first power? That's going to be 1, right? Excuse me, my bad. 1/2, right? My input was 1. My output was, let's write this again. F of 1 is going to be 1/2. Now, when x is 2, as x increases, right? What's 1/2 squared? Where did the square come from? It came from the exponent right over there, right? What's 1/2 times 1/2? 1/2 times 1/2 does not equal 1. You multiply straight across, right? So, let's use blue on this. F of 2, when x was 2, is going to be 1/4. Let's try f of 3 on your own. Okay. Now, as x gets bigger, let me write this in pink. Okay. Let's use a different color, lime green. As x increases, notice how x, my input, increases. What happens to my output? Where's my output? Let's use blue. No, let's use purple. I like purple. My output is here, here, and figure out what that is. And did it get bigger or smaller? Did it increase or decrease? That is the question. Good luck, and I'll see you tomorrow, Miss Dunn. Bye-bye.